Hi, welcome to Mrs. Park's Algebra 1 class. This is Chapter 2, Section 6, Ratios and Proportions. Okay, why? Ratios allow us to compare many items by using a common reference. The table below shows the number of a certain popular fast food restaurants per 10,000 people in the United States as well as other countries. This allows us to compare the number of these restaurants using an equal reference. So, common popular fast food restaurants. Okay, so here's some delicious fast food places. So we're trying to compare these, a popular restaurant with other countries. So number of people's per restaurants per 10,000 people. So United States 0.433, New Zealand 0.369, Canada 0.352, Australia 0.349, Japan 0.282, Singapore 0.273. So obviously the United States have the most restaurants per 10,000 people, the most fast food restaurants. Okay, ratios and proportions. The comparison between the number of restaurants and number of people is a ratio. A ratio is the comparison of two numbers by division. Okay, so it's using division to compare two numbers. The ratio of x to y can be expressed in the following ways. So you can write it three different ways. You can say x to the y. You can write the word to, or you can use the semicolons x dot dot y, or you can put x over y. These are all same ways that you can express the same ratio. So suppose you want to determine the number of restaurants per 100,000 people in Australia. Notice that the ratio is equal to the original ratio. So 0.349 restaurants over 10,000 people. But if you want to compare it to 100,000 people, you multiply 10, and you will also multiply 10 on the top as well, so it's now 3.49. An equation stating that two ratios are equal is called a proportion. Okay. So we can state that this proportion, this ratio and that ratio is equal. So it's a proportion. So you multiply by 10 on the top, multiply 10 on the bottom, and you get this number, and they're still equal. For example, determine whether ratios are equivalent. Equivalent is another word for equal. Determine whether 2/3 and 16 over 24 are equivalent ratios. Write yes or no, justify your answer. So are these equivalent fractions is what they're asking. 2/3 and 16 over 24. So 2/3 is divided by 1, simplify it's already 2/3. 16 over 24, if you simplify it by dividing by 8 here, you get 2. Divide by 8 here, and you get 2. So you get 2/3. So yes, they are equivalent fractions. They're the same number expressed in different fractions. Okay, so here's your turn 1A and 1B. So determine whether each pair of ratios are equivalent ratios. Write yes or no, justify your answer. Okay, when you say yes or no, you need to tell me why. So is 6/10 same as 2/5? Okay, if it is, tell me why. If it's not, why not? And you need to justify your answer. If you want to go back and look at how they did in the previous slide, you can do that. So make sure you do 1A and 1B and come back when you're done. Okay, welcome back. Alright, there are special names for the terms in a proportion. Okay, so when you have a proportion, so 0.2 to 0.5 equals 1.2 to 9.0. The middle numbers are called means, middle terms, okay? And the outside numbers are called extremes. They're the first and last proportions. Key concept. Means, extremes, proportion, property of proportion. Okay. In a proportion, the product of an extreme is equal to the product of the means. That means A over B equals C over D. Or A times D equals B times C. Since 2 over 4 equals 1 over 2, the equivalent fractions, when you cross multiply, 2 times 2 is going to equal 4 times 1, because 4 equals 4. Alright, so cross products. Use cross products to determine whether each pair of ratios forms a proportion. So if you cross multiply and they're equal, then yes, they are proportions. So 2 times 14, does that equal 3.5 times 8? 28 does equal 28, so yes, the products are equal, so the ratios form a proportion. So another example here, 0.3 times 2.0, okay, does that equal 1.5 times 0.5? 0.6 does not equal 0.75, so no, they are not it does not perform a proportion. So here's your turn 2a and 2b. So go ahead and cross multiply and see if they're equal. So write yes or no if they're equal or not. Okay. Solve proportions. In order to solve proportions, so this time you're going to cross multiply to determine what the x is. So x times 5 you write as 5x. 10 times 3 is 30. So 5x equals 30 is what your equation is. Divide by 5 on each side and you find out x equals 6. Here's another example. It's a little bit more complex this time. So when you cross multiply, you're actually multiplying this whole thing with a 7. So x minus 2 times 7. And then you're multiplying 14 times 2. Okay. So here is where you use the distributive property. So 7 times x, you write as 7x. There's the minus sign. 7 times 2 is 14. 14 times 2 is 28. Okay, now you have a two-step equation. You can add 14 on each side. Okay, add 14. And add 14 here. That's gone. Now you have 7x equals 28 plus 14 is 42. Then you divide by 7 on each side and you get x equals 6. Okay, so all we're doing is cross multiplying to write it on an equation and solve for x. Okay, so here's your turn numbers 3a and 3b. So go ahead and do those two numbers and come back when you're done. Okay, welcome back. So the ratio of two measurements having different units of measure is called a rate. For a rate. For example, a price of $9.99 per 10 songs is a rate. A rate tells you how many of one item is being compared to one of another item is called a unit rate. So here's a real world example of rate of growth. Retail. In the past 2 years, a retailer has opened 232 stores. If the rate of the growth remains constant, how many stores will the retailer open in the next 3 years? So past 2 years, 232. How many stores do you think they'll open in the next 3 years? So we're going to write a proportion. Well, first we'll let R represent number of retail stores. Okay. So 232 in the past 2 years. How many do you think they're going to open in the next 3 years? So do you see how retail stores on the top, years on bottom, stores on top, years on bottom? It has to be consistent. Okay, so 232 over 2 equals R over 3. So let's cross multiply. So you have 2R equals, I generally like to write the one with the variable first, so 2 times R. Instead of putting 232 times 3 on the left side, I chose to put 2 times R on the left side. On the right side goes 232 times 6, which is, let's see, 2 times 6 is 12, carry the 1, 18, 19, carry the 1, 12, 13, 130, 1,392. So then we're going to divide each side by 2. Okay. So now I finally have R equals divide this by 2. 2 goes into 13 6 times. That'll make it 12. 19 is left. Times 9, 18. 1, 2, 12, 6. And you can totally put this in the calculator. I was just trying to in my head. Alright, so 696 retail stores will likely open in the next 3 years. Alright, so here's your turn number 4. Exercise. It takes 7 minutes for Isabella to walk around the gym track twice. At this rate, how many times can Isabella walk around the track in a half hour? Okay, so 7 minutes to walk around twice. How many times can she walk around the track in a half hour? Okay, so you have minutes, how many times, so you have to be consistent, minutes over time. Okay, so make sure you do number 4 and come back when you, actually that's the last slide, so that's it. Make sure you put your homework away for credit, and thanks for watching.